Intro to Solutions and Aqueous Reactions. Solution concentration with a focus on molarity. In this tutorial, I will be going over solution concentration, which, we'll be going over molarity, molarity worked examples, and then finally, molarity putting it all together. So let's start talking about molarity, which we are going to represent as a capital M. Molarity expresses the concentration of a solution as the amount of solute in moles divided by the volume of solution in liters. So the relationship that we're looking at here is moles over liters. So when you label your molarity answers, you can represent it as a capital M, or you can represent it as moles over liters, as they mean the same thing. So one more time, molarity is equal to the amount of solute in moles, which is key, divided by the volume of solution, that will be your solute and your solvent, in liters. So the first example that we're going to look at is when we're determining the molarity of a solution when we're given the amount of solute in moles, which is good for us. And in this case, the volume is going to be given to us in milliliters. Now, one conversion factor that you need to be aware of here, or remind yourself of, is that 1 liter of any type of solvent is going to be equal to 1,000 milliliters. So we need to keep that in mind. So in this particular example, determine the molarity of a solution containing 0.0376 moles of NaCl in 23.7 milliliters of solution. The first thing that we always need to do is write out our formula. So molarity is equal to moles over liters. Now, before I go any farther, I'm going to go back and look at my example, and I know I'm in moles of NaCl. Great, I can put that in the top, not a problem. But I have 23.7 milliliters of solution, and I need to get that into liters. So if I start with milliliters, milliliters needs to go on the bottom. 1,000 milliliters is equal to 1 liters. And then I'm going to cross out my milliliters. Those units go away. So 23.7 times 1 divided by 1,000 will give me, make my little equal sign there, 0.0237 liters. So now I'm in liters. I can go back to my molarity formula now, and I have 0.0376 moles of NaCl divided by my volume, which is now in liters, 0.0237 liters of solution, which is going to be equal to, if I divide that out, to 1.59 molar. And I know by looking back at my original numbers, I have 3 significant figures here, 3 significant figures over here. My answer is in 3 significant figures, so I can label it as 1.59 molar, or another acceptable way of labeling it is 1.59 moles over liters. And that's an example of a molarity problem where you're given moles, but you're given milliliters of solution, which we're realizing here we need to change into liters before we can go any farther. Okay, let's look at another example. In this situation, we're going to be determining the mass of solute needed. So we're looking for mass of solute needed given the volume of the solution in liters and the molarity of the solution. So we're given volume, we're given molarity, we need to find the mass of solute. Okay, determine the mass of copper 2 sulfate in a solution with a molarity of 0.750 molar and composed of enough water to make 1.50 liters. Fantastic. So molarity is equal to moles over liters. We're given a molarity here of 0.75 molar, that's my sad looking 0 right there, God that's awful, is equal to moles, which we're going to solve here, and our liters is 1.50 liters of solution. So I'm going to be solving for moles. I am going to cross multiply here, and when I cross multiply here, I find that the number of moles is 1.125 moles of CuSO4. And I'm not going to worry about significant figures at this point because I need to do more. That's moles. I don't want moles. They tell me that I want mass, which I know is grams. So I'm going to say to myself, all right, 1.125 moles of CuSO4, multiplication sign and a line. I know that in every 1 mole of CuSO4, if I find the gram formula mass of that, it's roughly 160 grams of CuSO4. And then moles of CuSO4 cancels moles of CuSO4. So when I work this out, I'm going to have 1.125 times 160. And when I do that, I find that it is 180 grams of CuSO4. And again, I look back at my original numbers, 3 significant figures here. When I work this out on my calculator, it is 180 grams of CuSO4, so I'm going to just put a decimal right there to make it look all pretty and say, hey, look, I did it to the correct number of significant figures. So everything is good in the world. So in order to figure out the mass of the copper 2 sulfate, it is 180 grams. Okay, let's look at our next situation. Determining the volume of solution. So we're going to be looking for the volume of a solution given the solution concentration, which we know means that we are going to be given a molarity. As a molarity, hey, I just said that, and the amount of solute in moles. So they're giving us the molarity, they're giving us the moles. We need to solve for volume. So determine the volume of 0.750 molar AgNO3 aqueous present in milliliters. We're going to have to keep that in mind here. When 0.0600 moles of AgNO3 is added to water. Fantastic. So molarity is equal to moles over liters. The molarity given here is 0.750 molar AgNO3 equal to 0.0600 moles of AgNO3, that's supposed to be a G, divided by my volume. So that is what I'm looking for. Now I need to solve for liters here. So I'm going to move my variables that are given to me around so I can isolate the volume by itself, which means I'm going to rearrange this so liters is equal to 0.0600 moles of AgNO3. I really need to work on my G's. Divided by 0.750 molar Ag. That was better. NO3. And then when I work this out, the liters that I find when I do my calculations are 0.08 liters, which you might think to yourself, hey, I'm done. It's all good. I found liters. They asked for the volume, but then we go back to the problem and we see that the final answer needs to be in milliliters. So we all know that multiplication sign and a line, 1 liter is equal to 1,000 milliliters. Liters will cancel liters. So this is going to be equal to 80.0 milliliters as our final answer. So in this case, the big thing to pay attention to was they gave you a molarity, they gave you moles, you were solving for liters. Highly suggest, as usual, to write out the formula, isolate what you're solving for, making sure that you're labeling, and then finally making sure that you're in the final unit that is required from the problem. All right, molarity, putting it all together. Calcium hydrogen carbonate, CaHCO3 reacts with HCl according to the equation below. So look at it, I gave it to you, I balanced it, how nice am I? Calculate the volume, so we're looking for volume here, of a 0.235 molar HCl solution required to react completely with 0.140 moles of the calcium-containing reactant compound. Goodness. So we need to calculate the volume of the HCl. And we have a molarity of the HCl. We want volume, but we don't have moles. But we do have moles of the calcium-containing reactant compound. Why didn't I just say calcium hydrogen carbonate? Okay, whatever. Maybe it's trying to make me focus more. So I need to get out of moles of the calcium-containing reactant compound, which is 0.140 moles of CaHCO3, and I need to get 2 moles of HCl. Well, this looks like a mole-to-mole problem to me. So if I go up to my balanced equation, I see that there is a coefficient of 1 in front of the CaHCO3. So 1 mole CaHCO3. Extend that out a little bit. And then I notice there is a 2 coefficient in front of the HCl. So 2 moles of HCl, because I need to get to moles of HCl. So moles of CaHCO3 cancels moles of CaHCO3. They cancel each other basically. So when I work this out, I'm going to get 0.28 moles of HCl. All right, so always remember, people, when in doubt, convert to moles. I mean, that's the big thing. Or in this case, convert to the moles of the stuff that you want. Now I'm going to go back and say I need my molarity formula. So molarity is equal to moles over liters. Okay, so they give me a molarity of the HCl. And the molarity of the HCl is 0.235 molar HCl equals, and now I have moles of HCl, 0.28 moles of HCl, and I'm trying to find volume again, just like our previous problem. So like before, I'm going to rearrange my problem, isolating my variable of volume. So liters is equal to 0.28 moles of HCl divided by 0.235. I guess I didn't need to put the 0 in front, but whatever. Molarity HCl. I am isolating liters, and when I divide these two numbers together, my volume is going to be 1.19 liters of HCl. Little h there. Okay, so did we calculate the volume required to react completely with the moles of calcium-containing reactant compound? I do believe that we did. All right, let's continue on. Okay, so we have the same reaction as before with the calcium hydrogen carbonate reacting with the hydrochloric acid, my HCl, considering this is all an aqueous solution, to produce my products. Awesome. Now we are trying to determine the number of moles. All right, the number of moles of water. All right, we have to keep that in mind. Moles of water produced when 0.491 grams of the calcium-containing reactant compound combines with excess HCl. Hey, there's that word, excess. And as soon as we see excess, that means we have so much of this HCl that we're going to be able to consume all of the calcium hydrogen carbonate. So this is not a limiting reagent problem, thank goodness. So what's the one number that they give us to start with? Well, it's 0.491 grams of CaHCO3. That's an A. Yeah, it's definitely an A. And if I go with my mantra for AP Chem and I'm in grams, we all know that we need to convert to moles. so now I need to get into moles of calcium hydrogen carbonate. So 1 mole of CaHCO3 2 divided by my gram formula mass of calcium hydrogen carbonate, which is 162 grams of, I guess we'll be good, CaHCO3 2. Okay, so now I'm out of mass and I'm into moles, but do I want moles of CaHCO3 2? No, I do not. I want moles of water. So I'm going to put in my next conversion factor. So I know that this is going to be a mole-to-mole section. So moles of CaHCO3 2, and I want moles of water, moles of H2O. I'm going to go up to my balanced chemical equation. And where's water? Oh, here it is. Water, right over there. So for every 2 moles of water produced, I need 1 mole of calcium hydrogen carbonate at the beginning. Before I go any farther with my calculations, I'm going to make sure that all my units cancel. So grams, cancel grams, moles, cancel moles. I'm left with moles of water, which is what I want. And when I work this problem out, this is going to be in standard notation 0.00606 moles of water, or we could put it in scientific notation, which would be 6.06 times 10 to the negative third moles of H2O. And I believe this is mission success here. Did we determine the number of moles of water produced? Yes, we did. So what did we learn in this tutorial? Well, we went over solution concentration working with molarity, and then I did a bunch of examples, and then we put molarity together with a bunch of previous concepts that we've done in former units. Need more help? Feel free to contact me. Have a great day.